Sir, hindi pa po recorded attendance ko, sir. Attendance ko po ngayon, sir. Wala pa na record sa Excel, sir.
Sino nga ito?
Abon, sir.
Dabon? Yeah. Dabon de Jesus. Andyan.
Present po, sir.
Kararating lang?
Yes po, bago-bago lang po ako, sir.
Okay. Wala na. Okay. Before we proceed to the new topic, let's look at the exercise. Did you do the exercise? Everyone? On page 110?
Yes po, sir.
Let's read that again, no? Page 110. Mali yata ito. Bakit mali? Ninth edition. Page 111 pala, no? Sorry. .15. Okay. So, 3.15, and let me open again the ninth edition. 3.18. It refers 3.15 refers to the figure in 3.18. Ito, no? Do you follow? We have studied this before when we looked at the execution cycle of load and store. Do you follow? So for example, load is memory read and store is memory write. It shows here that the status of the bus, no? The status of the bus, no? There are three cycles, okay? T1, T2, and T3. And the status signals, whether we have write enable, no, write, read enable, are available all throughout T1 to T3. So hindi nawawala yung control signals, no, status signals, that are, whether the memory is available or the bus is available, hindi nawawala. Okay, and the address line is slightly after. Okay, slightly after T1. Okay, so anyway, the actual memory write or read will happen in T2 and T3. Okay, do you follow? Okay, yun ang sabi dun sa example, no? Address enable, which means that the memory address from the memory address register, which is used during memory read and memory write, is also available right after the address line is available. Okay, this is normal because you cannot write enable, or rather you cannot address enable the memory address register during the read, no? Hindi pwedeng mag-address enable kung wala pa yung address. Do you follow? So the value of the memory address register is set up first before the address enable is done, no? And right after that, no, the address enable is removed during T2, which means that the address is already in the bus and it's been read properly, no? Nalagay na doon sa bus, okay, and then the memory is configured to read the address already, read or write the address. Okay, now during the read, no, the data lines are output into the memory buffer register. Diba? Dalawa lang man yan, memory buffer register and memory address register. The final output is in T3. Do you follow? So the memory buffer register or MBR is valid and at the last cycle. Okay? Kasi during the data read. During a data write, wherein we write the memory buffer register, okay, into memory. Kung sa read, baligtad. Ang galing sa memory papunta sa MBR. Okay? Kung sa write, okay, galing sa MBR papunta sa memory buffer register, which means that the data at the memory buffer register is ready during T2 and T3. So the write can happen, okay, also in between T2 and T3. Okay, and it will probably finish before T3. The read can start happening during T2 and will terminate in T3 just before. Kung tingnan mo, una matapos ang read before the data lines are in the memory buffer register, because it ensures that the memory buffer register has the right data during the read. Okay? Do you follow? So what's our problem? Ito yung problem. Okay? The Intel 8088 it's an 8-bit. Okay? The Intel 88 is an 8-bit microprocessor. 8086 yung 16-bit. Do you follow? So ibig sabihin 8088 ang kanyang memory address register, ang kanyang memory buffer register is 8-bit. Pero ang kanyang address yata is 20 bits, no? 1 megabytes. Pareho sila. Okay? It can read, write 1 megabytes, no? Okay. But this time, this requires 4 memory processor clocks. The valid data is on the bus for an amount of time, okay, starting at the second cycle of the clock, okay, and extends to the 4th process cycle. So ibig sabihin kung ito, no, galing sa dito, may T4 sa the valid data, both in and out will extend in T4. Okay, so may T4 dito. So sa T4 siya magano. Okay, the valid data is the bus for extension for the 4th processor clock cycle. Assume a processor clock of 8 megahertz. 8 megahertz. Okay, do you follow? So itong 8 megahertz, 8 megahertz times 4, no? So if you have 8 megahertz, we'll use an Excel, no? How many times will it read? Okay. How many cycles will it take to do a memory read or a memory write? Anyone? Ilang cycles? Gusto natin malaman yung data transfer rate. We can only know that if we will know the amount of time needed to do a memory read or memory write. Do you follow? What's the clock cycle? Clock frequency? It's 8
megahertz.
8 megahertz. Anong ibig sabihin ng 8 megahertz? Okay.
8 million cycles,
8 million
per second.
cycles per second. Okay, therefore sa one period, ito, no, let me look at that. Itong one period na ito, it determines the amount of time needed, okay, for one period. But we are told that there are 4 periods. We need to know the amount of time needed for this, and then we will multiply it by 4. Do you follow? Okay, so that's the number of bytes because it's a parallel, ano, so this will take 1 byte per second, 1 byte per 4 cycles. One period is 8 megahertz. What's 8 million? Megahertz is million, di ba? Okay, so we will divide that. Baligtad rin, no? The inverse, no? Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 100 Okay. Nano. No? 125 nanoseconds. Nano is 10 to the 9, di ba? It's no. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 124 nanoseconds. Do you follow? Let me Google that to make sure. Saan yung ako, ano? Nano. Ilan daw? Whatever it's called, basta we know that it's not, it's millions, no? 125 millions of a second. What's a nano multiplier? Ten to the 8. 12.5 nanoseconds kung ganun. Do you follow? 10 to the 9, no? Do you follow, Nano? 10 to the 9. Do you follow? So I am correct, no? So it is 0.00. So if we move this 9, this is 124 nanoseconds. Do you follow? So 124 times 4. Why? Because there are 24 now. There are now 4 cycles. Okay, it's 496 nanoseconds. Okay. So it's a point. So what? 1 byte. So it reads 1 byte per 496 nanoseconds. Okay.
Oh, sir.
Yes.
Sorry, sir. Di po ako bakit po 124 instead of 125 po, sir?
Ay, 125 ay sorry. No, nalibat ko kamay. It's 125, no? Sorry. 125 nanoseconds. Type. So, kung 125 times 4, that's 600 nanoseconds. No? Okay. So we'll have 1 byte or 8 bits per 8 bits per 125 nanoseconds. Ano, that's 125 to 150, di ba? Times 4, 500. Okay, 500 nanoseconds yung it will be able to read 1 byte, okay, for 500 nanoseconds. So how can we reduce that, no? 1 equals equals 1 over, okay, so 1, 2, 3. Paano yan? Paano natin ma-convert yan? Okay, ang 500 nanoseconds. 500 nanoseconds is 1 byte per second. So we'd like it to have in terms of seconds, no? So times 10 times 200, hindi kasi at 20, it multiply natin ito by, it move natin by 3, 1, 2, 3, 2 kilobytes per second. Okay, do you follow? 2 kilobytes per second kasi move natin ang ano maging times 3, 1, 2, 3. Yes, that's 2 kilobytes per second. How did I compute that? Because the number 500 nanoseconds, you invert that becomes the frequency. Like if you have 8 megahertz, the total number needed is 125 nanoseconds, di ba? Yung 8 megahertz, okay, ang time nun sa isang clock cycle is 125 nanoseconds. Times 4, we will have 500 nanoseconds, which means that in our diagram, nawala itong akong diagram, no? The 4 cycles will take 500 nanoseconds. And it will take 2 kilobytes per second. Kasi in those times, all of the bytes, 1 byte, no? 1 byte is transferred, no? 1 whole byte. Byte tayo na dito, no? Because the 8088 will read 8 bits at a time. Okay? Do you follow? Any questions so far? Tama ba? Okay, it's just an exercise between
Ay,
family.
sir, saan po nagkuha yung 2 kilobytes?
I-invert mo yung i-invert mo yung 1/500. We have 500 nanoseconds ito, right?
Yes, sir.
So, hindi actually hindi na natin kailangan i-convert into megahertz kasi we know that this is now nanoseconds times 10 to the 9. Okay, do you follow?
Yes, sir.
So ang isang period is 10 to the 9. That's the amount of time needed to read 1 byte. If 1 byte is read in 500 nanoseconds, how many bytes will be read in 1 second? I-invert mo lang yung 1/500. Do you follow? Do you get my point? So it will read 2 kilobytes per second. Yun yung speed ng 8088. 2 kilobytes per second. That is considered fast during that time, no? But that's very short. That's slow as of modern standards. Do you follow? Katulad dito, di ba? 800 megahertz, which means that in 1 second there are 8 million cycles. So 1 cycle is 125 nanoseconds. Now there are 4 cycles, it will take 500. So if there are 500, 1 byte is read in 500 nanoseconds. How many bytes are read in 1 second? I-invert mo lang yun. Do you follow?
Ay, sir, diba ang nanoseconds rin po, sir, kay yung 10 raised to the -9. So, so I think hindi siya applicable na 1/500 lang siya, sir.
I-text na natin. Baka mas malaki, no? Times 10 to the -9. What's your answer to this?
Answer ko po dyan, sir, kay 2 megahertz per second. Ay, megabytes per second, sir.
Oh, yes. 2 megabytes ba? Okay, 9, you know. I'm sorry. Kay nanohertz kasi ito. So there's a 10 to the 9 here. So equals that, no? 1 over. Tama daw. Hindi pala 2 kilobyte, no? Okay, nano is in the inverted mega. Equals 1. Equals 1. And so sorry. Equals 1 divided by this times 10 to the 9. Kaya niya ito. 10 to the 9. Okay? So that's 2 megabytes. 2 million ito, no? I'm sorry, I'm wrong, no? 2 million, right? So that gives you 2 megabytes per second. So okay na ito, no? Ito yung speed, yung 2K per second. Masyadong mabagal yun. Do you follow? Tama yun, no? I'm sorry. Nalimutan ko yung 10 to the 9. 2,000 bytes per second. 2 million bytes per second. Kasi 1 whole byte is read during the 4 cycles. Any questions? What if there are 5 cycles? So ganun din, gawin natin itong 5. Do you follow? Okay, so this is slower now. Okay, kung 5 cycles, it will become slower because it will have a wait state, which will add 1 cycle of 125 nanoseconds. Okay, so for 5 cycles, it will take 1.6 Mbps. Do you follow? No? Do you follow? Kasi this is, in letter B, 5 cycles na daw instead na 4 cycles. Okay? Okay. Any questions so far? No? Okay, so yeah. Actually, very self-explanatory lang naman, pampagulo lang naman yung mag-hertz, di ba? Let me open. Bakit walang memory na? Any questions? So let us proceed to the next topic, which is memory. This may be our last topic, no? You can download this in our sa 7th edition pa ito, but the 7th edition in terms of memory, no, is very similar with the 9th edition. Both 8 and 9 edition. Ang 9th edition kasi wala nang libreng wala na siyang libreng slides. Okay? Do you follow? So we'll be using this as our but we will adjust, no, in terms of the problems. Okay? Cache memory ang nito. Cache memory ang main topic. Okay? So you know what cache memory is, right? Sino hindi alam kung ano ang cache memory? Okay? So anyway, we'll define it here, no? So memory is defined according to its location. Anong ibig sabihin ng location? Location with respect to the CPU. Di follow gaano siya kalayo sa CPU in terms of connectivity. If it's connected within one bus, no? If there's a direct connection between the CPU and memory, the memory is called internal memory. Usually it's inside the processor. You follow? But if there is no direct connection between the memory and the CPU, the memory is called secondary memory. Okay? So main memory is internal because it's inside that processor. The set of registers are internal. No? They are called internal memory. The cache is also an internal memory. Do we have a figure for the cache? Oh, ganito yung kasi yung cache, no? Do you follow? Now, if you've seen your motherboard, di ba, may lalagyan ng memory slot. Okay? Can we Google that? Motherboard. Have you opened your? Have you seen a motherboard ito? Ano lang? Kung ito yung motherboard, you have the PCI slots. You have the memory slots. Dito may ilagay yung DIMM. Okay? Nandito yung CPU. Which means that the memory is not part of the CPU chip. Okay? So, okay. There is a connection. There's usually a the cache. The main memory is outside the chip, but the cache is inside the memory chip. No? Do you follow? So kung ganito yung the CPU and the cache are in one IC. No? One IC. Okay? So it's a very small amount of fast memory, and it sits between the normal main memory and the CPU. And in terms of location, it's located second nearest. It's not the nearest because the nearest are the set of registers and may be located on the CPU chip or module. But nowadays it's standard. No? When you buy a processor, you will have the cache inside it. No? So that's why there's a big difference between performance. There's sometimes a significant difference in the performance of an AMD processor compared to an Intel processor because of the size of the cache. Do you follow? So dito sila sa cache nagkakatalo. In terms of the speed of the CPU, there are downsides and upsides. There are positives and negatives. Kaya lang, pagdating sa cache, dun sila nagkakatalo. Because how fast they access memory will determine how fast the programs will be executed. And because they transfer from main program is fetch, no? From main memory to CPU. That's a stored program concept. Okay, do you follow? I'm sorry. So internal internal memory is inside the processor. Sometimes if it's inside the the motherboard, it's still considered main memory, no? Okay. So an example is a set of registers and the cache, no? They are called internal memory. No? Secondary memory when they are outside of the CPU motherboard, like for example the disks, no, your USBs, devices, and so on and so forth. Now we also classify memory in terms of capacity, no? So magkaiba ngayon ng mga DIMM RAMs, no, depending on the slot or on the package. The RAMs are classified accordingly. No? So the capacity of memory is expressed in terms of bytes. No? So you will have the smallest now. You have a 4 gigabyte memory in one slot. Likewise, the external memory is also in terms of bytes. Now, units of transfer. Now, units of transfer is sometimes referred to as words, no? Which means that how many units of memory is being transferred at a time. Okay? It's usually equal to the number of lines in and out of it's the size of the bus, no? The size of the memory bus. Nowadays, no, we have a 64-bit processor with a 32-bit bus. We follow, which means that if your processor is 32-bit, or rather is 64-bit and your bus is 32, masayang yung dalawang cycle. You will have to waste 2 cycles because in order to read two words, which is 32, dalawang cycles. Do you follow? Okay. So I'm not sure the size of the bus currently, no, if it's still 32-bit. But the normal is you will have a 64-bit processor with a 32-bit bus. Can we Google that? Effective kasi hindi na parallel ang PCI Express, PCIe. Kasi in the first place ngayon, the bus is the bus is serial na. So it doesn't matter whether you will have a conventional 32-bit ang kanyang slot, but it's serial, so the effective we really do not know, no? Hindi na mag-matter ngayon kung 32-bit ang bus o hindi, as long as the memory is 64-bit. The unit of transfer is sometimes called a word. So normally nowadays, one word is 32 bits. Do you follow? 32 bits. No? How many addressable units? No? How many units are addressable in memory? The addressable units may not be equal to the actual memory. For example, our IBM PC can gigabytes. Kasi kung sa 16-bit, you can have 32 gigabytes. Do you follow? And then, kung 64 bits, you will have a lot more. But, you may have 32 gigabytes addressable memory, but it may not be the same memory that is installed. For example, you will have 32 bytes addressable. Yung memory address register is 32 bits, but the actual memory is only 4 gig. Do you follow? So how much maximum memory, okay, can be accessed? Okay, this is usually determined by the size of the memory address register. Okay. Now, for external memory, no, data is not transferred according to words, but they are transferred according to blocks, which is much larger than a word, because it usually is inefficient to transfer one word at a time. No? So blocks are transferred. No? So, wala na itong mga sequential access method, no? Direct and random na ngayon, which means that any address can be accessed at any time. When you say associative, it's like a stack or a heap, okay, where data is stored, can be stored according to the contents of a portion of the store, which means that you can hash. Okay, for example, in the cache, you can create a hash function that will point to the location in memory that data can be stored. We will talk about that when we talk about associative mapping of the memory cache. No? Access time, no? How many bytes per second? Memory cycle time. Okay, time may be required. So may mga wait states kasi, no? Sometimes, no, the access time may not be, maybe smaller than the memory cycle time because of the wait states. And the bottom line is performance is measured in terms of the rate at which data can be moved, no? Megabytes per second. Okay. So semiconductor na ngayon, no? Okay. Ang RAM ngayon are semiconductors. We don't have magnetic tapes. We still have optical DVDs, but we use USBs and SSDs. No? Physical characteristics, decay and volatility. What do we mean by decay? How long after, no, data is applied will data be lost? No? Volatility is whether it requires power to maintain storage or not. Like for example, hard disks and SSD are non-volatile because even without power, they retain the values that are stored to them. But RAM is not volatile because without power, the value in the RAM is lost. Erasable, no? Nowadays, no? Memory is erasable. How much power consumption? 3 volts man tayo ngayon, maliliit na ngayon yung power consumption. Organization, no? Ganito yung bottom line. How much is the capacity and how fast is memory? And of course, the third is how expensive. The good news is memory is getting more and more efficient, no? Cost efficient. Okay? Because technology improves. May bagong technology ang Intel, promise nila 2 years ago, no? Or 3 years ago, that they will have produced an SSD, which will be almost as fast as memory. Ang galing, no? Okay. So ang pinakauna, registers. Registers are as fast as the CPU. The second is internal memory. Okay. They are not as fast as the CPU. And the third is the external memory, which are hard disks, and they are the slowest types of memory. So ganito yung memory hierarchy. Okay. The higher you are in the hierarchy, the smaller, but the faster. Okay. The higher you are, the smaller and the more expensive. And the cost is inversely proportional. The higher you are in the greater the cost. No? So nandito yung inboard and registers and cache main memory are the first in the hierarchy. The second will be the outboard storage. So hard disks, no, nandito. Okay, and then SSDs, and then offline storage. Okay, like USB. Okay, wala na tayong mga magnetic tapes, no. internal memory hierarchy list. So ganito yung how can you arrange according to, this is actually arranged according to location, no? We have registers first because they are directly addressable, like yung mga MAR, MBR, IR, no? These registers are directly accessible by the CPU on the ALU. Now after that, we'll have the L1 cache and the L2 cache. Now we have L3. L3 na kasi ngayon, luma kasi ito eh, no? L3 na tayo ngayon, wala nang L4. Meron pa bang L4? Which means L1 means level 1 cache. L2 means level 2 cache. So sometimes, no, cache can be very expensive. So it's also subdivided in 2 levels. The more expensive cache is L1. The least expensive cache is L2. And the cheapest cache is called L3. So dinidivide sila into levels. And L1 being the fastest is also the most expensive. L2 is the next most expensive and faster. The slowest is L3. But L3 is still faster than main memory. Okay. Now, another important question is not only the speed of memory or size of memory, but how do you transfer memory data from memory so that it will be efficient, it will be fast and efficient. Now, the main issue is there's a big difference between the speed of the CPU and the speed of the RAM. No? So if you have a 2 gigahertz CPU and you will have a 2 Mbps RAM or gano ba 1633? Okay. 1633 means you will have 1633 16 okay. It's 1.6 gigahertz. No, ang speed ng yung RAM, yung mga bagong may aabot ng 2.3, di ba? Yung mga DIMM na bago. DDR. Okay. Itong sa akin is I think a low end 1.6 no gigahertz. Now your CPU is 64. Your CPU may be 8 gigahertz, but your memory is only 2.6 or 1.6 gigahertz. So exponentially faster. Okay. Is it possible to build a computer with only one RAM? Nowadays, it's not. If it's possible, it should be a very fast RAM. Okay, do you follow? It's not possible because the CPU speed is too large, too fast, no, compared to the RAM speed. That's the reality. Masyadong mabilis yung mga processors, masyadong mabagal yung memory. Okay. Now, we cannot build very fast memory, a very large memory, no? Very large and very fast memory. Why? Because it should be very expensive. Mabilis na malaki, masyadong mahal. Do you follow? So, there's a need for a certain type of memory called a cache. What is a cache? It's a temporary storage. Temporary storage lang that is used to access parts of memory to the CPU. So before the CPU accesses memory, it goes through the cache first. No? So lahat ng ma-access sa memory will be passed through the cache such that it's the CPU that looks for data from the cache and the cache fetches data from memory. Do you follow? There's a need for that because memory is too slow compared to the CPU. Now, a cache is a certain type of memory which is much smaller than main memory, but which is much faster than main memory, but not as fast as the CPU. Parang middle tier na siya, no? The speed is between the CPU and the internal RAM. Okay, that's called a cache. No? Now, the good news is there's a balancing factor. Although mahirap magkaroon ng malaking memory, there's a balancing factor. Okay, there's a principle that is called the principle of locality of reference. Can somebody explain this to me? You've been programming for years, right? What does this mean? Anyone? Ano ibig sabihin ng locality, principle of locality of reference? This is important to when we discuss the cache, the concept of cache. It's the nature of programs to be closely knit, closely tied to each other. Diba? Programs come as a sequence of commands, and this sequence of command are closely located to each other, right? Hindi naman pwedeng you have a command in line 1000 and the next command that follows is in line 1,000,000, right? The command usually follows at the next byte after it. And if there's going to be a jump, it's not going to be too far away, as in megabytes far away from the current location. Diba? So when programs make references, they are usually memory references. They are usually limited to a certain locality of addresses, no? Within, shall we say, 1 megabyte address or 2 megabyte address. Memory references will not be too far away from the current location. Okay? How can we compare this? For example, if you have functions calling each other, then functions should not be very far away, because programs are by nature contiguous. Contiguous, nag-follow yung mga procedures from each other. So hindi naman pwedeng meron kang isang malaking program that's where the commands are, the calls are very far, no? The procedure calls are very far. Magkalapit lang talaga yan sila. Like repetitions, loops, no? If then else, no? Programs are contiguous and memory references tend to cluster over a certain range of addresses, no? Do you follow? So that's the main basis of the cache. Okay, if the CPU is going to execute a program and it cannot transfer byte per byte commands from main memory because main memory is very slow, what is usually done is to use an intermediary. Okay, a smaller amount of very fast memory. It sits between the main memory and the CPU. Okay, what the cache does is, hindi naman pwedeng, it's like a pipeline, temporary storage, no? Such that when a certain address is being accessed from main memory, the cache will not just take 1 byte, it will take all the bytes, okay, that are within the locality of the address being accessed. Now, that's called a block. Okay? Hindi siya kukuha ng isang isang byte lang. Kukunin niya isang block that belong to the same locality of the whole address. Okay? From main memory. So that when CPU runs that program, it is limited to that block and it will never have to access main memory more frequently. So hindi niya kailangang mag-access ng main memory more frequently. Because kung nandun sa cache yung block, ibibigay na lang ng cache, and cache is giving it much faster than main memory. However, if the content is not, the memory reference being requested by the CPU is not in the cache, that's when there will be a wait state where the cache will have to reload a block in main memory into itself, so that it can now service the CPU again. But it doesn't happen frequently because of the principle of locality. Hindi masyadong mag-block transfer, no? Paminsan lang yung block transfer because the cache has already loaded the whole locality of the address being So, ibig sabihin yan na if you are going to ask a block of voters, parang block voting during elections, di ba? Instead of asking the voters to vote one by one, that's what the politicians are doing nowadays, no? One by one, kukunin mo na lang yung buong block so that when you call the voter, most probably nasa block na siya. Okay? You don't have to go back to the locality and get the voter because the whole block is already there. Okay? So ganon. Now, if the voter is not there, then that's when the time when you have to request for another block. Okay? So ganito yan. This is main memory, this is the cache, no? Sinabi na ba niya? Okay. So, hindi pa. Okay. So we can divide memory into fixed size blocks. Usually a power of 2, such as 1 megabyte. If your memory is 4 gig, we can have blocks of 1 megabytes or 10 megabytes. Pwede pa rin 10 megabytes. Malaki pa rin yung 10 megabytes. Okay? You have fixed size blocks. So you have 10 megabytes byte blocks. And then in the cache, you will have smaller number of blocks. Okay? Shall we say we have here 124 blocks, 128 blocks, and in the cache we will have 16 blocks, being power of 2s, no? So follow, kung 132 blocks, ito 16 blocks, okay, which means that, okay, some blocks in memory are present in the cache. Do you follow? Not all of the blocks are present in the cache. They are only needed when the blocks that are loaded into the cache are those that are within the locality of the address being requested by the CPU. So for example, when the CPU is given an address, no, the cache will determine saan block siya kukunin. Okay, if it's going to be taken from a particular block, it's loaded there. If it's already, the block is already in the cache, there's no loading that will happen. The CPU will just give the content of the block, or rather the cache will just give deliver the content of the block to the CPU directly. Okay, CPU. So this is the sequence of operations. Now, first, the CPU requests for an address from memory through the cache. No, magre-request siya ngayon ng address sa cache. That the cache will check for this data if it's within one of the blocks. Okay, so let's say 10 blocks. Anong sabi natin? 16 blocks, because 16 is a power of 2. It will look for if the address is in one of the blocks. If it is there, it will going to fetch that value from that block. Okay, so it's very fast because it's usually there. Now, if not present, then the required block is taken from main memory to the cache. This will be the time-consuming operation, because aside from taking, determining the block, it will have to determine where in the cache will the block be located. Saan siya ilalagay? Okay? Pagkatapos ma-identify kung saan yung location niya, then the cache will check if that location has an occupant. Okay? Kasi kung baka pala yung block na yun ginagamit. Do you follow? If it has an occupant, the current occupant will be saved back into memory. If a flash, that's called flash. If a flash has a memory, para its states will be preserved. Okay? And after that, when the cache is flashed, then only then is the new set of contents be loaded to the cache. And then the cache will deliver the data to the CPU. Okay, the cache includes tags to identify each block of main memory during each cache slot. I-determine natin ito, no? Ito yung flowchart niya. Okay, sorry. Now, next meeting, anyway, we will, paubos na tayo, no? We will not have time. We will identify the different types of block replacement algorithms. Okay, used by the cache, no? Ito yung ano niya. Ito yung ano, receive an address from the CPU. RA. RA is just the name of it. Is the block containing RA in the cache? Yung address na yon, is there a block containing RA? If yes, fetch the RA word and deliver to the CPU. If no, access main memory for the block. Actually, it's not, no? Allocate, kasali na dito. Allocate cache line for main memory block. Ibig sabihin, i-allocate niya yung cache. Ibig sabihin, kung meron ng dating na occupant, yung block na yon, it will have to save it back. and then make it vacant properly, and then load the memory block into the cache line and deliver the memory word to the CPU. And it goes back, no? Pareho na sila. Most probably the whole block is there. So the operation of the CPU will be restricted to this straightforward process. Okay. So the cache design is factors, no? The cache. The size of the cache is important. The bigger the size, the lesser will be the memory replacement, no? The mapping function. How do you map the blocks of the cache into the blocks in memory? How do you replace the blocks? Okay. How do you determine the block size? How do you write? What is the appropriate block size? And what is the number of levels of cache? No? Cache is more expensive, it's faster. Okay, and so on and so forth. So ganito yung cache, no? Nandito yung processor. Ang address ng galing sa memory address register. Ang data comes from or to the memory data register. So dito kukunin if the address is in the cache, ang cache na ang bahala, no? Ang cache na ang bahalang mag-communicate to the main memory. So these are the differences of processors, no? Hanggang dito lang siya, no? 2004 lang. So for example, the IBM S360 has L1 cache, 16 to 32 KB. The first Pentium computer, problema lang ito, wala siyang AMD. Ang mga AMD kasi ang malalaki. In 1993, has an L2 cache. Ibig sabihin, the first level is 8 KB. The second level is, depending on the cost, no? May iba na 256 KB to 512 KB. 8 KB is fast, is very fast. 256 KB is much smaller. Okay? Now, pagdating ng 1999, no? The L3 cache became popular, no? With L1 as 32 KB, 256 KB of L2 and 2 MB. The lower you are, the higher you, the bigger level number, the bigger the size, but the slower the speed. Okay? Hindi niya sinali yung mga AMD. Huh? Now, next meeting, we will discuss direct mapping. Okay? Could you watch the video? Medyo complicated ito eh. No? Could you watch the video by there that I've associated? Direct map cache. Okay? We will discuss this next meeting. No? And I will give you another set of exercises to do. Okay? Dito matitest yung mathematical abilities. Actually, it's just binary arithmetic. Okay? So ito yung mga okay. I'll try to look for a more updated source, no, in terms of that. You can easily Google that, no, processors and their cache. So CPU performance nowadays is not just in terms of number of cores, but also in the number of levels in the cache. No? Kasi ang memory rin kasi ang significant in terms of identifying the performance of a CPU. Kung gaano kabilis ang performance, total overall performance ng memory is also an aspect. Wala sa example. Basta ang alam ko ngayon, ang mga AMD medyo mabilis, no? Maganda yung cache ng AMD computers, especially ano ba itong sa akin? Basta mabilis. Okay? Baka meron sa dulo. Wala siyang table. Okay. Any questions? So, wala muna tayong assignment ngayon, no? Wala muna assignment. We'll have an assignment next meeting. Okay? Any questions, everyone? I'll give you And then we will discuss direct map cache. Watch the video ahead, no? Kasi medyo mahirap intindihin, no? Okay. Anyway, I have examples there in Dagler. We'll go through exercises and examples. No? So thanks everyone, and good afternoon.
Thank you, sir.
Yes, sir.
Bye.
Bye, sir.
Bye, sir.